Hello, students. So, welcome to 6.2, mass and volume to moles. That's what we're going to learn about. We're going to learn about how to convert masses of something, masses of lead, masses of iron, into moles, like our friend Morgan Freeman here. But before we get that, it seems like a couple of people could use a little bit more practice with going from moles into atoms, molecules, or formula units. So let's talk about that first. So let's say we have 12.6, we'll just do 12.6 moles. And we want to convert this into formula units. So how are we going to do that? Yep, we're going to use our conversion table. And our conversion factor is 1 mole equals 6.02 times 10 to the 23rd formula units. What's going to go where? Yes, we want our moles to cancel. So they're going to go down on the bottom. That means formula units needs to be up top. So we have 1 mole down at the bottom, and how many formula units is that equal to? It's always Avogadro's number. It's always 6.02 times 10 to the 23rd formula units. So let's math that out. I think this is where some people are getting worried. Let's do a little bit of math here. I'll show you exactly how I want you guys to do it. So we're going to write down 12, look at that, 0.6. I'm going to put in, we're going to say multiplied by, and we can put this all in parentheses, 6.02, and this whole thing times 10 to the 23rd. And it's divided by 1, but we don't have to worry about that. So we multiply that out, we jam it into the calculator, and we get 75.852. And again, this is all times 10 to the 23rd. But that is not scientific notation. So we can write it again. We're going to move this decimal place to the left, which means we need to add 1 here. And we get 7.5852 times 10 to the 24th, because we added 1. Move left, add 1, which also we can show as 7.56 times 10 to the 24th, because we have right up here 3. We have 3 sig figs, so we want to end with 3 sig figs, so that's what we have. Our answer is, we cross things out, obviously, 7.59. I already did this math earlier. 7.59 times 10 to the 24th. So let's talk about mass into moles, and then actually, if it's a gas, we can do volume into moles. So let's talk about that. Again, atoms, they're tiny. We don't want to count them. It's ridiculous to count them. So we count them indirectly by using the masses. Using mass, and that way we can then go to moles and calculate how many atoms we have. But we need to know the average weight. We just need a little math. Where do we get the average weight, the average mass? That's right on the periodic table. We use the periodic table in order to get our atomic mass, or our average mass. And this is the exact same thing that people do if they had like a jar of jelly beans or small candies or bolts. If you figure out the mass of 1 jelly bean and you figure out the mass of the jar, you could theoretically calculate out how many moles or how many jelly beans you have. So the way we do this is with molar mass or formula mass, and we've been doing this in class. But to remind you, the mass of 1 mole of a substance in grams, you always can figure out from the periodic table. It's equal to the atomic mass on that periodic table. And the units are grams per mole. And the molar mass, or the formula mass, is always the mass divided by the number of moles. If we're talking about 1, then it's an easy conversion factor. So formula mass, or molar mass, is the mass of 1 mole of an element. You use the periodic table. Let's do an example. Carbon, we look on our periodic table. We see carbon in the upper left, the number with all the decimals, 12.01 grams equals 1 mole of carbon. Sodium is 22.99 grams. Equals 1 mole, and francium is much larger, it's much heavier, as they say, it's 223 grams for 1 mole. If we wanted to figure out for a compound, we're just basically doing the same thing, we're just multiplying, or we're adding to make sure we compensate for all of the atoms. Again, periodic table, calcium chloride. We know we have 1 calcium, but since calcium has a 2+ charge, we need 2 chlorides, so it's CaCl2. And we add the mass of calcium, 40.08, plus 35.45, plus 35.45. That's our mass for the 2 calciums. And altogether that equals 110.98 grams in 1 mole of calcium chloride. Calcium carbonate is CaCO3. We're going to use, if we wanted to name that, we would use our ion charges sheet again. And calcium is 40.08. We have 1 carbon, it's 12.01. And then, since we have 3 oxygen atoms, it's 3 times 16.00 if we are rounding that 15.99. And that equals 100.09 grams per mole. So let's calculate some moles from a given mass. If we have 1 mole of carbon is 12.01 grams. Let's say we have a sample that has 5.00 grams. Let's figure out how many moles is that. We're going to use the periodic table, and we're going to use that molar mass. So we have 5.00 grams. Again, we use our conversion table. This is just another way to write it. So we have 5 times 1 divided by 12.01. And we get 0.416 moles. How many sig figs do we have at the beginning? That's right, we have 3. And then how do we have at the end? 3. It's almost like magic, guys, except it's just being awesome using your sig figs. So now we're going to talk about something a little different. Let's talk about volume. So for any volume, we can't use volume of a gas or a gas. So let's talk about molar volume. Since if we have a mass of something, we have sodium chloride, or we have a bottle of liquid, of water, we could figure out how many masses that is. But what if we have a gas? What if we're talking carbon dioxide gas? Like we wanted to know how many moles we're dealing with global warming that's caused by carbon dioxide. So you have to use something different. What you use is a volume, because for any given gas, 22.4 liters equals 1 mole of that gas, as long as we're at standard temperature and pressure. And that's 1 atm, and that's 0 degrees Celsius. So think of a cold day on the beach is standard temperature and pressure, because you have 1 atmosphere of pressure at sea level. STP is an abbreviation for that. And again, this only works for gases. You can't talk about the volume of a liquid. You can't talk about the volume of a given solid. It only works for gases. And an example of gases are the diatomic elements. So hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas, bromine gas, or iodine gas. So let's do a calculation here. If we have 1801.23 liters of a gas, how many moles is that? So you have 1801.23 liters. We're just setting up another conversion factor. So we have 22.4 liters because we need those 2 liters to cancel. Up top, how many moles is that? Yep, it's 1 mole. So let's figure it out. That is 75.0513 moles of that gas. Super simple, guys. So I want you guys to try this, especially if you are having problems with the Moodle quiz. I want you to figure out how many moles are in 1.20 times 10 to the 24th molecules of dihydrogen monoxide. I want you to figure out how many moles are 15.6 grams of hydrogen gas, and what volume would 3.7 moles of chlorine gas occupy, and what's the molar mass of aluminum sulfate and sulfur trioxide. I will give you tickets this time, and or allow you to earn one homework pass if you can solve all of these perfectly correctly. So good luck with that. So let's find the mass of 1 mole of each of these. Cobalt alone has CO for its formula. Aluminum sulfide, what is its formula? We have 1 aluminum, Al2S3. Potassium nitride, what is its formula? K3N. Dinitrogen trioxide, N2O3. And carbon diselenide, CSE2. So what are going to be the formulas? I'd like you guys to check these to make sure that you can do this. This is great practice for you. Cobalt is going to be 58.93 grams per mole. Aluminum sulfide is 150.17 grams per mole. And potassium nitride is 131.31 grams per mole. Dinitrogen trioxide is 76.02 grams per mole. And carbon diselenide is 169.93 grams per mole. Make sure that you can do this. If you are not getting these correct, you're going to have a very hard time. So, I hope that that was helpful. Let me know if you have any more questions. Bye-bye.